Good morning, students. We come to limits. I'll show you the limits, few sums based on different types. So we write the limits types over here. The first is the direct substitution. Okay. So direct substitution means, say we get a question like evaluate limit x tends to 1. I took an example, x square plus 1 by x plus 100. Okay. So here we get actually the sums like this. So if we put 1 into it directly, so there is no problem because we get a non-zero denominator. So if the denominator is non-zero, we can directly put over here. So we get a 1 square plus 1 by 1 plus 100. So it's not a problem for us at all. So 2 by 101. So this will be the answer. Okay. So this is one of the direct substitution type sum. I'll choose another sum. I'll write another sum in the meantime. So I get another sum from NCERT 13.1, exercise number 13.1, question number 11. Here also x tends to 1, this is a function, there is no harm, we can put 1 into it directly. So this is also a direct substitution sum. So you can just put the values of x, so you get a plus b plus c by also c plus b plus a, which is also a plus b plus c, and you get a 1. Now the division is possible because of this condition given, a plus b plus c not equal to 0, which means it's a non-zero number. That means you can divide it and 1 is the answer. So this is almost over with the direct substitutions type. Next we will discuss a type which is called factorization. So I will write a sum before that just to describe the thing. Okay. So if I take a very easy sum, say like x square minus 8x plus 15 by x minus 3 and x tends to 3. So we face a problem over here because if you use the direct substitution method and try to put it over here, you will get a 0 by 0. Look at it, it becomes, the denominator becomes 0, 3 minus 3. Okay, and this also becomes 9 minus 24 plus 15, which is also 0. So this is a problem, so which gives you some kind of undefined thing. Okay, but we have to be a little alert that if this kind of undefined thing comes in our answer, we have to observe this, that the limit answer could be different and we need to apply the other methods. So what we do over here, if we do the middle term factorization over here, I get x minus 3 and x minus 5. Look at it, it's a quadratic polynomial which can be written like this. So x minus 3. Now we can cancel this x minus 3 and x minus 3. X tends to 0, x tends to 3, that means this is x minus 3 is non-zero. So we can cancel this, leaving behind what? Limit x tends to 3, x minus 5. And now we can just put easily the value of x over here, 3 minus 5, and we get a minus 2 as answer. Okay, so this will be a factorization type. I'll write another factorization sum for you. So I wrote a couple of sums over here. We will do question number 7 first from exercise 13.1. So if this is the case, you know, like if we put a 2 over here, it will be 4 minus 4, that is 0. So it becomes undefined again. And this polynomial, quadratic polynomial, if you put 2, it will become 4, 3, 12 minus 2 minus 10. So this is also 0. So that means x minus 2 is a factor of it, right? So that means you can factorize it, middle term factorization you can proceed, and you can do something like this. It's x minus 2 and something like over here 3x plus 5. Just check whether it is correct or not. 3x square minus 10. Okay, and below you get a square minus b square, where you get x minus 2 into x plus 2. Again, what we do, you know, we can cancel out x minus 2 from both numerator and denominator, leaving behind this, and you can put the value of 2, because now you will get a non-zero denominator. So it will be 6 plus 5 by 2 plus 2. So 11 by 4. So this is the answer. Now one more thing is that please always write this limit extends to the value part over here till x is present in your sum. Okay. Now this sum, see, I have not done. This can also be done by factorization and cancellation, but we will try to do this in a little easier way by application of some formula. So I write here a formula, algebraic formula type. The formula I give you, that is limit x to the power n minus a to the power n by x minus a, where x tends to a, is n minus 1. Okay, I write here clearly n minus 1. So this is the formula I write for you. So this formula I will use, because sometimes it's, if when higher powers are there, like say x to the power 100 or something like that, it might be difficult for us to factorize. So what I will do, here I will write first like this, x to the power 4, 81 becomes 3 to the power 4. So I will bring a x minus 3 over here, and I will write an x minus 3 over here also, so that it's a kind of adjustment. It's a kind of adjustment. And this 2x square minus 5x minus 3, here also I have tested that if I put a 3 over here, it becomes what? 18 minus 15 minus 3, which is also 0. Right. So I will get x minus 3 factor over here also. If I factorize this, I will get 2x plus 1. See whether the factorization is correct. Okay. Now when I do this, automatically this will be cancelled with this. Okay. Now after this, what I will do, I will use a L1.L2 type. L1.L2 is what? The product of limits of two functions. So I will just separate it out. Limit extends to 3. So it resembles the formula. See, it actually resembles the formula over here I have written. X to the power 4 minus 3 to the power 4 by x minus 3. This is my L1, and what is L2? L2 is extends to 3, 1 by 2x plus 1. So obviously that formula, I know I'll get the answer. What is n? N is 4. So 4, 3 to the power 4 minus 1. Okay. And here you can directly substitute, because we observe a non-zero denominator. So 1 by 6 plus 1. So the answer becomes, here you get 3 cube means 27 into 4, which is 108 by 7. Okay. So this is the answer over here. So I got the answer as this. Please understand this thing. So I broke up into L1 and dot L2, applied limits on both the functions, and I got the answer. I get another sum, question number 10 from exercise 13.1, that is this. This I will also try to apply the formula. See, it's z to the power 1/3. This can be done in many ways. You can do it in a cube minus b cube form also, but I will try to apply the formula. Let's see what happens. So I will write a z to the power 1/3 minus 1 to the power 1/3 by z minus 1. Okay. Now this is my L1. So I directly wrote in one step. Just I am writing this z minus 1 over the top, because there is a z minus 1 I have divided. So this is z to the power 1 by 6 minus 1 to the power 1 by 6. Look at it. This is also this formula and this is the reciprocal of that formula. Okay. This is the same only, but it's the reciprocal. So here when we write n is 1/3, 1/3, 1/3 minus 1. So that will become 1 to the power anything, you get 1. Into, it's a reciprocal. So it will be inverse of this thing. So 1 by 6, n is 1 by 6, 1 to the power 1 by 6 minus 1. So this we got. That means we got 1/3 by 1/6. Okay, which is 2. So 2 is the answer. Okay, next we get another sum. Here we will learn a type. It's the rationalization type. Okay, so we will write the rationalization type. So here the same problem is there. We get a 0 in the denominator. So we will try to rationalize this and do the sum. So let us rationalize this. You know what to do. Root over 2 plus x plus root 2 you need to multiply. So if I rationalize this, I'll just show you once. So this is the there. So you immediately get a minus b into a plus b, which is a square minus b square, and you get over here 2 plus x minus 2, right? But one thing is important. Don't forget to write limit extends to 0. Over here again and again I am saying to you that Again, I'm saying that this should be written. This is the condition, limiting condition. So you can see only x is there in the denominator. So we can cancel it, but here cancellation cannot be done. It's in one step. So you can ignore it and write like this in the next step. 2 plus x and root 2 over here. Still we need to write limit extends to 0. Why you know? Because x is present in the sum still now. And this will be, you put it x equals to 0, so 1 by root 2 plus root 2, you get a 1 by 2 root 2. So this is the answer of the sum. So one more sum we will do in rationalization method. One more thing is that we get one more sum over here from rationalization. One thing I will like to tell you to check always, that get a 0 denominator, then only start all these things. Otherwise sometimes you might get fooled by the sum. The sum will give you, already giving you a non-zero denominator, and you are doing so many things. So here if we put 4, we get 1 minus 1 0. So okay, so we Rationalize this. A plus B, and this one also, so double rationalization. So whatever I have written over here, I need to write over here also. That means 1 minus 1 plus root over 5 minus x, 5 minus x, okay, and this is the adjustment for this, and adjustment for this is 3 plus root over 5 plus x. So a square minus b square on the top for this will give you 9 minus 5 minus x, and this 1 minus 5 plus x, right. Limit x tends to 4, and here the same thing is there. One plus root over 5 minus x, 3 plus root over 5 plus x. So here you get 4 minus x, and here you get minus 4 plus x. So I will take a common 4, so I get like this. Okay, just do the calculation like this, you will get this, and then you can see the problem area is gone. We can eliminate the problem area, that is 4 minus x is gone. Okay, the 4 minus x part is gone, you can cancel it, and leaving behind L2, which is like this. I don't need to exaggerate this again. Okay, so leaving behind a minus sign in the front because of this, and 4 if you put over here you get a 1, so 2 by 4 if you put you get a 9, that means 3. So 3 plus 3 6, so the answer is minus 1/3. I hope you have understood this. So thank you for today.